Hello. Alright, I think this is live. So, today I'm going to be doing... let's hope this is working. I really hope this is recording. But today I am doing PicoCTF 2024, the binary exploit challenges. I haven't done this stuff for a good amount of time, but we'll see how it goes. I have my font size so big, but hopefully that means you can see it. Anyway, let us get started, I guess. So I go to Pico24, the pawn, and alright. So I guess first off, let's download this random stuff. Right, yada yada. And let's see what we're working with, right? We got... No, let's do... Oh, what? Okay. Alright, so what we have is... Here's the main. Why are the functions everywhere? So, we do what? We serve Patrick. So, it prints some random stuff that I don't care about, and then, oh yeah, I guess I didn't even explain what binary exploit is, but all it is you have a program that's hosted on some sort of service usually, and then you want to make it run not the way it's supposed to, usually with some memory corruption or something. Anyway, so then, right, so this program is going to be served by like the PicoCTF servers probably. Hopefully it still works. And then, yeah, we'll try to make it and give us like shell access or something. Alright, so if we look at the... We have a menu, okay. And then we see, wow, look at that, right? It's a printf that's not very well formatted, as its format string. We're probably doing some format string exploit. So let's see what serve Bob has. So seems to be scanning in something into our buffer, right? Is there even... And really it looks like we can just do a buffer overflow, I think. Right, is there anything preventing us from going over? I'm not sure. Well, let's see, let's just put in flag test, right? I'll put this back up, right? Hopefully you can read it. So, I mean, let's just run the program, right? That's the easiest way to go. And then string 0. Wait. And then string 0. Anyway. Alright. So we have to choose from those, right? So what does it want us to do? We have to like choose one of these things, so let's just copy it in. Okay. What? Let's just input this, I guess. Alright, let's serve in bacon deluxe, right? Fine. Where is this happening? So we choose one of these, we read it in, yes. And then, if it's not on the choice, it says there is no such burger. Otherwise, I'm supposed to print our choice. Okay, so first off, right, well, so what it wants us is to say, it wants us to say that the amount we're printing out is basically overflowing whatever this choice size is, right? So reading memory into the choice. Alright, I'll draw a little picture. I'll hopefully make it pretty clear what is happening here. So let's just move this over here, whatever. Alright, so draw a little picture. Right, what do we got? Got like a block of memory, and then we're reading. So the memory allocated at this size, I'm gonna read past it, and I'm gonna read twice as much, or the output of printf is how many bytes were printed. So you want to output, you know, at least that many bytes. Okay. Oh, but we can see, right, the only one that does it was this. What? Alright, so we need to do something like... Oh, what am I even doing? Anyway, well, I'm tired. I don't know what I'm doing. But read the choice. Yes, it needs to be on the menu. On choice. On menu. Choice menu. Read. What? Not on menu. Where's the on menu function? On menu, right? Okay. So we're only comparing the first 3 characters is the key part. And then after that, I'm gonna try inputting this one again then. And then, now let's like add some characters at the end. Okay, that's really it. What? I don't know what that's supposed to be testing, but it tested something. Which was probably like how dumb I am. So, you know, right? I mean, well, it'll show how to set up a little script. So let's, you know, import a little pawn, and then p is equal to process. No, we want p is equal to, we'll do process. What is it, e.path? I'm gonna do e is equal to elf of format a string 0, right? And then we're gonna set our comment for binary as e. And then we're gonna do something like this. And we're gonna change it afterwards to p is equal to remote of ema style. Alright, so this is just like using the library bundles to this process or remote is just going to be like a interaction to be able to interact with it programmatically, where when I say interact, I mean like send input and output. So first we're just going to try locally to say p.send line after. Alright, so this is just going to wait for the input. What? We want to wait for the input burgers. And then we just want to send what? Want to send, well, it only checks like 3 characters, right? So we're just gonna, let's make sure. Just gonna send like that. 3 plus, you know, let's just do 0. Something like this. And then the p.interactive is going is then going to let us interact with the program by hand, right? So you'll see what I mean. Obviously, I'm just explaining top tier, as you can tell. I usually do like what I I mean, what? We said on menu, right? Count. Oh, right. We're string comparing each of these. Sure. Oh, right. Okay. I'm sorry. We gotta actually copy the whole thing. I misread it. So the key is that the string compare only compares up to the length of the longer of the shorter string, I think, or something along that line. I don't even know. Right, it doesn't. So then we can just make sure we have the beginning right, and then just input some random stuff after, and then it still doesn't come to work. Why? What? Oh, well, first operate, we should input it after this. But I still don't know if that's the problem or not. Oh, I'm so washed at this. Oh, okay. I mean, let's just input this right. This one now. What in the world? Okay, so apparently, right when I was like interacting with it, I actually have no clue what happened, but whatever. It's just like one challenge, and then it wants you to do the next challenge, because I don't care. On menu, choice 2, menu 2, 3. Now we need something that's on the menu. Or does it even print the flag? What? Well, we just need it. Apparently all we need for the thing to give us a problem. Why can't we just do this times like 100 or whatever? Okay. I don't know what's going on there. Oh, my mind is not in it. But you know, it'll do better this next one. Trust. Gotta trust. Okay. Alright. So there's the first one. Well, that was not a good start. But it's okay. It's okay. You know. Only now. Oh, whoops. I'm gonna put this in a file. So let's just put this in this file, and then we'll go in it, and fix all that. Okay, so we finished the first one after a very sad amount of time, and hopefully I'll explain the next one more. Right, so let's get started with it. What is this? Oh yeah, I was figuring out this. Alright. Just copy this, and I need to make one. Alright, so here's the challenge. And let's download the source code, right? Cool. So let us look at the source code. Here what we have is some little menu thing. And a bunch of switches, right? So we can like print some heap, we can write some buffer, we can look at some variable, and we can see if we win. So what is the win state, right? I just want to look at that right away. So we win if something happens, yes. If, alright. We have to be able to change our safe variable. Sure. Oh, let's look at the init. So when we init, right, we're printing dumb stuff, and then we're just like allocating what? Safe var. Huh? Oh, we need to make it not equal to this, I guess, right? So let's do that. Oh yeah, I didn't explain the other challenge properly, but basically, any segmentation fault would cause the flag to print. So all I did was overflow the stack, right? So like, I'll explain on a different fault. Well, whatever. You know, this is like the worst walkthrough ever, probably, but that's okay. Alright. Yeah, it's putting like some stuff there and all that. And then what's our interaction, right? We can write buffer. What does that do? Write for the buffer. Okay. So what we see is that our input data is malloc, right? So there's like a heap that's like this big block of data. Let's open our writing app again. Okay. Yeah, sure. Let's put it somewhere. I don't care where. Right. Anywhere is fine. Right, but we're gonna have some big block of data. Right. Like the heap is just some big thing. And then when you alloc on the heap, you just like put some memory on the heap. Right, you're just gonna like put a little block, but then when you malloc the next block, well, the next block is like, because this program is so simple and there's like nothing else, right, the next block is just gonna go right after. And I could show you in memory, but I'm too lazy, right? So then now this thing, when you scanf, right, it's not checking the size of how much you input. So all you gotta do is it has like Pico and Pico, you know, just like write a big random string and it'll like change the next one. So, you know, and I'll just show you. Yeah. Alright, so let's like print the heap. Oh yeah, so it even shows you the address. That's very kind. Right, so you can see like where that's like the location memory. You can imagine you have like memories, some big giant array, and that's where it is in the array, right? And now, if we write, like just like a big amount of A, right? And print the heap. Wow, look at that, see? We changed this one as well. That's pretty amazing. Right, you can see here, it's right there. So yeah, that's kinda cool. And then now we just like would do 4. Oh yeah. Probably just a flag or something, I don't care. But let's quickly write program. And of course, I mean, I could just like do it on the server, but I don't know. I like to have a program for all of my things, so I can like look back on them and see what I did, I guess. I don't think I need to look back on this, but you know, shell, binary equals E, something like that. Is equal to process path, right? And then, you know, let's just right. It's gonna be like this. Sure. And I don't know, something like this, right? And all we're gonna do is like p.sendLine after. Let's look at it. Alright, so we're gonna p.sendLine after choice. Choice. We are going to send what? We're going to send 2, and then p.sendLine after. Alright. Now overflow chunk and right into next. So then now it's just like okay. Choice and buffer. Right, I don't actually need to put this, but whatever, right? And then like let's just do a times something like that, and then p.sendLine after. Right, and then it's just like ready for the flag and when we run that, what is going to happen? It says we win. Something happened. I don't actually know what happened. What actually did happen? Well, whatever. Let's see. Let's look at the code again. What actually is happening? So when it says you win, right? Alright, because I had nothing in my flag file. So then what's happening is there's just like random garbage in memory right here, and it was printing that. Anyway, now if we undo this, and so now it's connecting to the remote server, right, and just like inputting those things. Wow, that's amazing, right? Yep, my first heap overflow. So then let us go out of here and make a new little directory, right? And let's download our data again. And so, yeah, we download it over here, that's nice, and let's see what we have to work with first. So what do we have to work with? All we have is this one function, that's nice, right? And we have a few different things in memory, right? So usually they'll just be allocated one after another, so you can think on the stack, right? There's just gonna be a buffer, there's gonna be this like secret boy, and there's gonna be the flag and the secret. Right, so probably we gotta somehow, alright, it's gonna read in the flag, and we gotta somehow leak it. Well, let's see what we're working with, okay? So reading in all these files, and then it's like asking you, it wants you to, alright, this time, see, now it says 1024S, so you can only read 1024 characters. Actually, it will also add a null byte. I think that can come after 1024. I'm not too sure about that. Actually, I don't think that's true, never mind. But anyway, it will automatically append a null byte. But anyway, then like the obvious thing is, well, why is it like doing printf this instead of like printf %s, right? It's not using the format string, so then we can just like yeah, make it work or whatever. Yeah, so I'll show what's happening on this one just for fun. And test x string 1. Alright, so now to actually show what's happening, right, I have the like GDB extension, GDB PITA, which is just, I don't know, putting some automatic GDB configs in that make my life easier. What is happening? I don't know what is happening. What? I don't know what happened there. Alright. Anyway. so then if we just like break main and run, right? So actually I completely forgot how this worked, right? It's like disassess main, something like that. Okay, so this shows us where we are. So this is like the assembly code. Of course, like all the code is compiled to assembly, right? So then here, it's like allocating some data on the stack. We can look at the stack, right? We can say like telescope RSP. I forgot how you do this stuff. Alright, so here's like the stack, right? And then here's where we are. Well, now we're subtracting RSP a bunch, right, to make room for the arrays, right? So this is just like some random bytes that we're calling the stack, and it has like our variables and some other our environmental variables, and it has you know, like when you call a function, what are the return address? So then you can say like, how does, like, when the pointer, there's like just like a number saying like what instruction number are we on, but then it can like jump around when you jump to functions, but then how would it know where to go when you finish a function, right? Well, basically on the stack it just says like where was it before it jumped to this function. So then at the end of the function it's just going to jump there, and you can see before it's even calling main, even though that's like the only thing you see in the code, it was using some library calls to configure, right? And when it finishes main, it's going to go back to this library function and close everything out. That probably made no sense, but hopefully that was not in vain. Anyway, but if we step forward one, and we once again telescope RSP, whoa, look at that, right? Look, our thing like went backward from here, so that's kind of cool. And now this is where all our memory is, right? So I'm just gonna go forward again until our scanf. So let's just go to here, break there, and continue. Oh, what? Oh, okay, right. So let's like touch secret or echo. You take the into secret and you item 1, right? And then let's like echo meow into 2 and echo what flag into flag.txt. So let's open up GDB again. Main var main. Or we can just like go back over. Okay, so now I had it like just go run forward until right before it's about to read in our input, right? Call scanf. And now you can see, look at the stack, right? Oh yeah, it just shows the stack. Anyway, now the stack has our data. We do like what, telescope RSP, like what, 100 or something, right? Well, here's that string, here's our flag, and here's that other thing, right? And then, if you'll remember from before, where'd it go? Somewhere is the return to the libc. I don't know where it went. Oh, yeah. Anyway, for all that explanation to say, now when we look back at the scanf, right? So we're gonna read in our input and print it. However, if you remember from looking at the code, right? I think we can do like something like shell cat. Yeah, okay. So if you remember looking at the code, printf is like printing it directly. But if you look at printf right on the first thing is supposed to be our format, which is like these characters. But since we control it, we can just like say what character we want, right? So then what I'm gonna do is I'm gonna read in percent $6 sign. Sign. Oh no, where's some kind of pointer? Okay, I'm gonna pick some random one. Okay, so see like these values, right? I'm gonna be printing these values by inputting this. And let's look at what happened. When it prints it, where did it go? Oh, maybe that's not the one. Where's the print? What? Oh. Bro, where print it? Oh no, I have it. Probably did whatever that is. Alright, so I guess like that's like the top of the stack. Percent. I meant to do this. Now you can see, right, this $6 sign says we're gonna pick the 6th parameter, right? So when you have your format and you have like a bunch of parameters, you put a $6 sign. You have to pick your parameter, and we're outputting it as a pointer address. Very cool. So yeah, so now we just need to like do that with the flag, right? So let's look back at that stack we printed earlier. Where'd it go? Where is our stack? Okay, here's our stack, right? So now, this was like 6, right? And it's like each one of these is a number. We want to print the flag. The flag is here. So let's just do... Oh man. Why did you do that? Where'd it go? So I need what? We need to print AB0 minus A70. So B0 minus 70. What is that? That's like 4, right? It's like 40, which is really like 4 times 16, which is 64. 64 divided by 8. 64 divided by 8 is 8, plus 6 is 14, right? So now, if we do like the same thing, so we say 48 over P, we get this. Well, what is this number? Well, let's look back, and it should be the same as the flag. And it doesn't tell us, but let's hope that it is. If it's not, that's a bit of a problem. But anyway, let's like do it in code, right? Because that'll obviously make it easier. Or is there any pointer to it? Because that would just make life 10 times easier if there's a pointer to this address. AB0. Do we see anything pointing to it? Here, pointer, pointer, pointer. Where are you? No pointer, right? Yeah, it's just there in memory. But that's okay. Not the end of the world. Yeah, so what we gotta do is what? Alright. So we need to make our exploit. I spent way too long explaining that, and it probably didn't even make any sense. It was a waste of time for you, a waste of time for me, but that's okay, because now we're gonna go and code this stuff up because we can. I'll fill this in later, and then we're gonna do what? Send after, or actually, this time I'm just gonna loop through a few, right? I in range, like 8. Let's do 8. Okay. I'm gonna say p is equal to process path, right? And then we're just gonna say send line after u, and then we're gonna send what? Can I do that? I don't think so. I mean, can I just send a string? I don't know. Percent. It'll just be easiest to do it like this. Percent plus. I'm gonna do that. Percent I 48 plus I rather than P. Not receive until. Alright, so this is gonna receive. Up to here, order, and then we're gonna say what? S is equal to P dot flag plus equals receive line equals false, and then we're gonna say int. Right, so what we're doing is taking the integer because the %p is giving an address, so it's a hex address, right? And we're just gonna treat it as an integer. Wait, why would we do that, right? Because we want u64. Is that what I want? No. u60. Is that what I want? Maybe. We'll find out, right? And then we're just gonna print the flag and just like a log.info flag, and then we're just gonna say log success flag, right? Something like that. And is this what I want? I'm not sure. Let's just run it and see what happens. Wait, we need to actually like, wait, no. Wait, what is happening with this? Sure. Sent 48 plus I. What, does I need to like cast this as a string or something? What? Order. What is happening? What is it? Okay. I'm not sure what is going on there. Oh, wow. That was dumb. That was really dumb. I forgot that. Sure. Alright, so let's just get rid of this and hope it works now, right? Okay. So that's nice. You know, it's nice that it did not work. What did I say to do? Did I say 48? I do not think I said 48. I said, what? 64 over 8 is 8 plus 6 is 14. Okay. So that should work, right? Wait, I forgot. What do I do? Close. I gotta do that close or something like that. Okay, so then now let's like launch the instance. That looks like it's working. Hopefully you understood something about what I said. And yeah, so alright, so all it's doing is running the program 8 times and just like getting like 8 bytes at a time by outputting this. My explanation that was very bad earlier. I don't know if any of that made sense. It doesn't even make sense to myself, right? Hello? Mimas? PicoCTF. .net. It's just like taking forever. What's happening here? Yeah, okay. This is not wanting to start. Really? Come on. Is it just like not opening or what's happening? Hello? Ring ring. Hello? Ring ring. Hello? Let's restart. Ring ring. Hello? Ring ring. Hello? Are you serious? Oh my god. Oh, that's so sad. Does anyone look at my video? OMG, I had like a few viewers. That's awesome. Anyway. Alright. I don't know why this isn't working. Come on, man. That's so stupid. Five, 4, 9, 9. Well, seems there's not much I can do. I mean, look at the hints. What should I do? Well, that sucks. Whatever. It doesn't really matter. That's enough. Alright, we'll see if that... I don't know, maybe we'll try it again and it'll like magically work. But let's move on to heap 1. Right. So, as we go to heap 1, what do we have here? Gonna download our binary boy, and we're going to download our source boy, because, you know, why not, right? And we need to, of course, make our challenge executable and analyze our code, right? So it's another pretty similar idea. And what's the win condition this time? This time we have to set it exactly equal to Pico, right? So it's just like, I don't know, be more careful or something dumb. But I mean, let's just like copy our exploit code from heap 0 to here. Okay. Now we're gonna really change is that, right? I mean, I don't even care about it, right? We saw before it was like 20 bytes after something. Is that right? I think so. 20. There's no way it's 20. I mean, actually, let's do it the dumbest way possible. What? How could you say that? Pico. Oh, sure. Alright. Let's look at the challenge. Look at the difference. So it's a difference of 20, right? So like the only thing we really gotta do is say that we're doing a 20 plus this, right? Okay, so now let's have that run remote. And while that's setting up, I'll briefly explain, right? So like I said before, these two places, right, they're next to each other on the heap. All we're doing is writing a bunch of A's from B0 to, you know, E, C, F, and then at D0, we're just like writing Pico. And yeah, that's basically, it's like the exact same thing. But being slightly more careful with the addresses or something along that. So yeah, that is all that was about. Right, so now we can just like once again run it. And we got the flag, very cool, right? Very cool. What, oops, that was not the flag. Well, now we can go over to heap 2, right? Alright, so let's like download our stuff once again. And download this, right? And all the usual, make this executable, and let's look at the code. And what do we have here? It's like the exact same thing, but what's the new win condition? Win, oh, fancy, right? Okay, so now our check win is literally like calling X, which is some allocated data, right? Probably the same, yeah. So it's allocated a little bit after. We can just like look at it. Right? Oh, this time it doesn't print it, but it's probably the exact same, right? So now instead, right? So like this is calling an address as a function. So what we want is to call where in memory is the win function. But if we just like copy over alright, so then luckily for us, we don't have to think very hard because Puntools just lets us get the function e dot something. What is it? Oh, I do not remember. sim, right? It's like sim of win, something like that. Yeah. Alright, let's test it locally first. Right, so all this saying is, what is the address of win, right? And we're turning it into like bytes, so we can send that. So once again, we're just overwriting what's in x, but then now x is going to be called, and that's going to be the address of the win function. And you can see, right, you can use this function, this program, what's it called? Well, I'll think of it in a second, right? But you can like look at tools. What? Oh, whatever. Doesn't matter. Oh, what just happened? Maybe. Well, what is the stupid? Wait. Bro, I'm not. Okay. But yeah, this is saying there's no pi, right? So like sometimes binaries like where their base address is randomly loaded in memory. Actually, most of the time. But to make this easy, right, they make it be the same spot every time. So the win should be in the same spot every time. But for some reason had a problem. Not too sure why. Probably because I didn't actually have the flag.txt or echo flag temp. Okay, right. Now it works as expected. Well, what is that program called that checks the different like states of the thingy? Okay, there's some like terminal line command to basically print this info, which is useful, but I don't remember what it is. Tools check program whatever. What's the thing called? Terminal. Or what is it called? Right. What? Not this. Oh, I don't know what it's called. Oh wait, it should be in here. Yes. Check sec. Oh my god. Yeah, obviously you can see I'm not doing this in a long time. But yeah, if you do like check sec chow, it'll like show you if you have pun tools installed and you have to somehow install it. But then yeah, somehow right you can see this. And I'll briefly say right. So this is like how it loads the stuff in like the library, like your C standard library functions. It doesn't like put them all in the code, or this just says like it will get the stuff when it needs it, basically. And this is a thing on the canary. I already explained this, and this is saying whether the stack is executable or not. Where executable means like, can you run it in instruction like the assembly I printed earlier. Anyway, yeah, so we should be able to get this boy working. Six, 1, 5, 3. Right, so let's try again. Man. Oh no, it's the meanness. What does that even mean? Wow. Alright, so that was amazing, right? So let's just like input that and move on, okay? Another heap one. Let's look at this again. Let's like type ooh, and then alright, so on to the next one. Alright, okay. I feel like this is pretty useless for me and pretty useless for you, or whatever. Alright, so we got like this boy over here. Just gonna download it because it's like the exact same thing 10 times, which is obviously so fun. Alright, who does not like solving the same challenge 10 times? I'm just gonna launch the instance now, so I don't have to later. And you know, it's probably like I can just copy the code again, but we'll see. So the win condition this time is what? So we need, oh look, right. So this time, instead of x just being, instead of x just being a single string, right? And C, it's a struct with multiple strings. How cool is that, right? So then now, let's see what we got. Print alloc, alloc, free. Okay, now we got some more stuff going. So what happens when you alloc an object? What you do is you input its size, and you malloc that, then you alloc that, and then you can input it, right? So all it is, and when you free, you just like free stuff, so that's cool. Okay, so what is free, right? That's an important question. All it is, so in my explanation earlier, right, I said like when you add like new things, you know, it'll just, you know, kind of, what in the world? It'll just like put like a new kind of block thing, right? But when you free, you can say, I'm no longer using this block, and then now in the future, that would then mean, that since I'm no longer using that block, now if I alloc something again, well, it might be able to use that block because, right, you're no longer using it for whatever was there before, so now you can reuse it. So that's kind of cool, right? And like, why would you ever free memory? Because if you have big programs, you know, if you're like allocating a bunch of memory, right, you're gonna like run out of memory. You're gonna have to like do different like page loads and stuff, and that's gonna be slow, right? So it's better to just like try to reuse memory that's no longer being used when possible. So anyway, how does that relate to this? Well, here you're gonna, it's allocating x, which is like some block, right? So like, oops. So you have like your big old heap, going to be allocating x, right? Then what we're going to want to do is free x. So then we're going to say like, nothing here, right? Now we're going to allocate something of the same size as x. And then it's just going to fill in that spot again. And then we're going to, and then we're just going to like write in whatever we want there. Hopefully that made like a halfway sense. But anyway, let's just like, once again, no, same ordeal. Write it all again. Alright. Let's just fill in the remote now. So we have this stuff, right? I don't even know what's going on. But we're gonna put this thing here. And then, alright, what are our choices? Let's like go through it. So, we're going to want to free the object first, like I said. Now, we're gonna allocate something of the same size, right? It's gonna be like, it was like 10 times 3 plus 5. That's gonna be like, what, 16? I don't know, let's just say 32. And we're just gonna like add a bunch of random stuff. And then, I mean, let's just print it, right? I don't know. Did we get to see X? I don't care. So how big is x? It's 10 times 3 plus 5, right? Yeah. So let's just like do that and say, alright, so first off, oh yeah, I forgot to delete the comment from the old one. But anyway, let's like free x. Alloc new object same size as x. That will over be put where x used to be right in fake data x. Right, so now we're gonna say 2. We're gonna say the size is gonna be 35 and something like that. And data for flag. Alright, we're gonna allocate that data. Right? Data for flag. Why would you say that? Flag. And let's just do like a times 30 plus, what was it, like pico? What do we want it to be? We want it to be pico, yes. And then we're just gonna, yeah, hope that works, right? Hopefully like half of what I said made sense. Or like, maybe like one thing I said. I don't think I actually replaced, oh right, that's so good. It should be, yes, 5, 2, 4. Sure. Five, 2, 4. 5, 2, 4. Right? That should all be right. What was it? What was it doing here? Alright, we need a touch. Alright. Echo flag temp in flag. Let's see it go. Why is it taking so long? Probably because I put some name wrong. What's it say? Size of, why did I say buffer? It's size of allocation. Bro, what are you doing? Right, what am I doing? So we got the choice, we got the size of the allocation, and then, we put that flag. Oh wow, that worked, right? Very cool. So then now we can just like go ahead and change this to the remote because we can, and voila, right? Free real estate. I haven't even been reading the flags, but they might have been good. Oh. Right. I hope they weren't like funny things and I've been missing out. Everything is working. Come on. There we go. I mean, okay, let's try submitting our other boy again. Alright, because it's not working, so why is not that? So here's our exploit over here where we're saying, yes, alright, we're saying 5, 1, 4, 8, 5, right? We're trying to run that. There we go, right? Okay, this time it did work. You can see, right? Each time we're just reading 8 characters at a time. We're outputting that specific spot on the stack. Oh yeah, and I guess I didn't explain very well. But, so, the first 6 numbers, the first 5 numbers are actually in the registers, if you know what that is. Or I'll talk about them later, probably. But then after that, the rest of the variables, right? So if you have like a bunch of parameters for your format string, they're going to be on the stack. So that's why you have to say like the 6th one is the first one on the stack, right? And then we just like pick like the correct amount of offset to where the flag is on the stack, and then just print it out a few lines after. But anyway, there, right? That's so cool. So cool. And now we can go over to format string 2. Let's see, format string 2. And once again, let's like download our stuff. Okay. And what do we got this time? Alright, let's make it executable. And let's analyze our code. Why does it just give us the code? We haven't even had to use my best friend Gidra. But anyway. Alright, what have we got here? I don't even know. Let's get started. What? Wow, that's pretty sus. Alright, so we have a really simple function with the buff and the flag, right? Buff and the flag. Alright, so we're inputting some stuff, and then we're outputting it, and then we need a, oh, this time we gotta do a write. How cool is that? Right. It's not very cool. But anyway, it is true that we have got to write here. Yes. So you might think, right, just by outputting stuff, how are you able to write to a variable? That's like crazy. And it is crazy because it's stupid. But if we look back at the printf, right, we'll see a very stupid operator, the n, which writes to a variable parameter number, writes the number of characters printed so far, right? So, you know, you can think that's pretty dumb, and it is pretty dumb. And so now we could go by hand, right? Sorry, try to output. Well, first off, you might think, man, but that's like a lot of characters to try to output. You shouldn't output all at once. But you can do like, you can like use a modifier, which is this things. We're gonna want to do HH and only write one char at a time, right? And basically then we can only write like one char at a time to a certain address. Oh yeah, so what we have to do is we have to put the addresses on the stack, right? So then that's how we have the parameter of where to write. And then we just gotta output the right amount, the characters for like each byte, and then we write it to that address. Then we write a few more and use like the next address over and over. And luckily, PumTools has like a format string thing waiting for us. So that's pretty nice. Where is? Yeah. So, right. It literally has this built in, so you don't even have to think, and that's pretty cool. So, and of course, I don't like thinking, right? Nobody likes thinking. So, I'm going to yeah, I'm gonna not think, and I'm going to use this. So same setup as always. Oh yeah, you might be wondering, what does the context of binary do? Or, you know, binaries can be 32-bit, 64-bit. It can be like little endian, big endian. All depends like how the data is formatted. But, you know, if you like have this like binary structure, it automatically analyzes it. And then when you set this context of binary, then it'll like set like other settings appropriately, so you don't have to set what architecture you're on. But anyway, all of that out of the way to say, alright, so let's do process. And, you know, let's just like get this boy started too. But anyway, what were we doing? Some format string. Oh yeah, we were just like doing. Oh yeah. Okay. So, alright, we're gonna say like s is equal to what? Format string payload of what? It's gonna be 6. Oh yeah, so looking at the parameters, does this ever explain them? Yeah, so the start, that means like, what is the start offset for like our string on the stack? Well, I already said, right, 6 is the start offset, and our function, our variable we're writing into is right at the top of the stack. And then our writes, well, what we're gonna do is say, we're gonna write to sus. And we want to write the value what? I'm going to write whatever this is. Echo flag 10. We're going to make it equal to this value. Okay? So this like little structure also like is going to automatically say it knows where the sus variable is, right? And it's not very hard to figure out by hand, but you know, it's easier to just use that. And we're gonna tell it to write yeah, we want to use the format string payload because that makes life easy. Format Where's the function? I want to show it. Ooh, where did it go? Format string payload. Right here. The offset, the writes, num written. What is num written? Oh, okay. Yeah, so we don't care about that. Yeah, you can read what this says, but what we want is the write size. I'm going to say that write size is going to be what? A byte. Okay, it says that's the default, so all we really need is this, right? And then we're going to say that's inline after. What we're going to say after say. Yes. And then we're gonna like wait for that flag, right? We gotta pray my God, and then what just happened? Let's make sure we analyze this right. Buff, top of the stack. That true? Actually, I don't even know if that's true. Yes, it should be. Should be the top of the stack. Let's make sure S is printing over 1. Should be. Yes, no, pi, mathematical pi. What? I mean, either way. Wait, so what's happening? Got end of file. This. Oh, let's just do this too. Not that it should matter. Okay, for some reason, that's saying that's wrong. I mean, is this wrong then? Is it 5? Is it 7? I mean, let's just like try a few and like see. Of course, that's the best strategy. Okay, so what actually happened is for some reason the flag is lower on the stack. So we have to like go past the flag. So that's why we're starting offset. So that's like 8 more bytes. So 6 plus the 8 extra like longs that you have to go over. That's our starting point. But anyway, now we just like run that on the remote. Okay. Hopefully that made a good amount of sense, as in like none. But that made no sense, then yeah, that's what I would expect. And wow, look at that. I got the flag. That's so cool. Now, oh, good. We only have 3 challenges left. Now I can, like, you know, waste some time after. Which is good, right? That's my motivation for going fast. I just want to be able to waste time as soon as possible. I thought, you know, I haven't uploaded stuff for a while. So, like, maybe I should upload something. Even though, like, probably people only go on my channel for some programming, embedded programming stuff, which, you know, I'll do that soon, right? Like tomorrow maybe. But, you know, I'm just gonna like finish this and call it a day for today. Anyway, bro, another one of these. Oh, it does not get interesting after like the 6th time. Okay. Format screen. This is like the easiest year that I think I've done, right? I mean, like, they're pretty easy every year. Still, what are we doing with this? And that. Okay, so this time we have to also download libc, right? That's crazy. That means we're probably going to have to call some library functions, right? Remember how that one a while ago we called the win function? Well, now we're probably gonna have that pi turned off, right? Let's just make everything. Okay. Right, so let's do that like check set on the format string 3, and you're gonna see something. Bro, what? There's no pi. Okay, whatever. There's probably like, we probably need a shell then, I guess. So then, like, we need to call a function that gets us access to the remote server, which means we want to call like system or execve, right? But then, like, how do you get those address? Well, those things are in the libc, which is the library. It has all your print and scanf and all those dumb things. So let's like, anyway, but let's just like jump into the code and see what's happening, because yes, right. So this is nice and short, so at least I don't have to waste time reading. And it says, I hope this is working. Right, can you even see my screen? Oh yes, good. For a second, it looked like you could not see my screen on there, which would have been very bad. Anyway. Oh, I see. It's like, what? It's like very behind. Okay. Hope I don't know what's happening with that. But whatever. I hope you can also hear me. But then also, like, I'm like clicking my tongue a lot because I don't know. This is annoying me. And yeah. Sorry about that. Anyway, let us go to the next thing. I don't even know what we're doing next. What are we doing? I forgot. I guess we're doing this challenge by Mr. Scriblod. Got the setup and the hello. We got that printf. Very cool. So we're printing the buffer. Oh, first we get to input into the buff. This time with fgets. That's nice. Then we get to print that stuff. And then we print out a normal string, right? Okay. I forgot the name of the stupid function. Anyway, alright. Now, this might seem hard, right? You say, you have like this like printf, right? And we already showed we can do an arbitrary write with our printf. But then it's like, well then, what do you do after that, right? now. Oh wait, never mind. Oh. Never mind. I thought it was going to be some harder trick. But, okay, so it's literally like telling you one address in the libc, which means like you can get like the other address. So all it's going to do is it's going to output this address in the libc. Now the system address is going to be a fixed offset away. So you're going to take this right, and it's showing you that before. So then now you're just going to do the write to overwrite puts with the normal string. Oh wait, how do you overwrite puts, right? Well, what is happening when it calls puts? Remember I said earlier, there's like this partial railroad thing. Well, what it does is there lies like a list of what function addresses have been loaded from the library when you're using partial railroad. But the puts one will not have been loaded yet, will it? Or it doesn't matter if it's been loaded yet. But what you can do is you can overwrite whatever's on that list, right? So then you just gotta overwrite that list with the system. That's crazy. That's crazy. Should I show the GDB? No, I don't want to. Sorry. Yeah, but let's just like I want to write this all from scratch. So I'm just going to copy this over. And then I'm going to do some stuff. Alright, so I said there's like a list of things. Well, that list is called the GOT. You can look up whatever the GOT is somewhere else. But we want to overwrite this. Oh yeah, so get libc offset, and then oh yeah, actually one last thing. We have to actually make this program use the libc in dynamic linker. So to do that, we're going to use this little tool called patchoff. Alright, so now we're making, that's just like when we, let's print out this. Alright, so now this shows you what are the library dependencies of this. And now we can see our library dependencies are the ones that we just put in. Anyway, let's also just run it quick. Okay. So in the libc, right, so we want to read until libc and then read this in. Right, that is what we want to do. And then overwrite puts we've got system, and puts takes sh as parameter. We'll instead call. So we're gonna read it receive until libc, right? And then we're gonna say libc. I'm gonna say the libc.address is equal to p dot int receive line. We don't want the end character. That's in hex. And we gotta subtract the offset, which is the setBuff function. Okay, and then now we just say we're overriding the dot with now libc.sim. Right, so initially the libc address, it's saying like the offset is 0, so all these are the offset from the base address. Now we have the offset of the actual set buff, and we're going to subtract the offset and say that's where the base is. Oh yeah, we should actually have this right. Load info. Libc base x libc.address. Cool. Right. And now we're gonna do sim system. Something like that. Oh no. Now we're just gonna sim. And that should be all we need. That did not work, unfortunately, because we put the wrong file name. What? What have you done? Oh, right. So now this time, remember, now the only variable we have is like right at the top of the stack. So it is going to be that offset. What? Cat. Oh, that's not true. See, there's like some random stuff. So it's like trying to trick us, right? It's saying this stuff is going to be at the top of the stack, which is just like an array of pointers. So we got to do what? 32 plus 6, which is 38. And it might be like a little bit more than that. Look at that, see? Now we have access to our shell, because we just called it. But now when we do it remotely, we're going to have access to the remote shell. Right, so let's just like, you know, have that all happen. 49171. Very cool. Let's just like run that and whoa, look, we have access to the remote server. However, you might say like, oh man, we can see all the flags, that's crazy. But of course, like they're gonna have the challenge containerized, where like you have a Docker container set up that only has one instance you can imagine of the computer running. It's not exactly right, but that's how you can imagine it. So you can only access like these specific files that are set up for this challenge, but you still got the flag. Wow, that's so cool, right? So now we're just, oh my god, again. Okay, now only 2 left. That's pretty crazy. That's pretty crazy. 2 left. So far, the hardest challenge has been the first one, right? By far, right? I think that's the one that like took me the longest. But yeah, so probably because like I was like very out of it. But anyway, let's try it. Right, this time we got this game. Very cool. Oh, I didn't even like make the right folder. Baby game 3. Right, where's baby game 1 and 2? I think they're from last year. Baby game 03. But let's see what's happening, right? Oh man, there's no source. Oh no. Oh no. Right, what are we gonna do with no source? What we're gonna have to do is download this boy locally, right? We're gonna have to download this locally, and then we're gonna like input it into here. Alright, so Ghidra is a what, like a free decompiler, right? So it takes the assembly and attempts to, it shows you the assembly, and then you can also like attempt to see what what the C code that made that assembly is, right? To make it like easier to read. You know, when you're like weak like me, and can't read the assembly too well, because you know, yeah. But anyway, right? So you can just look at all the functions right here, right? So we can just read the code like this, right? See, here's the assembly, and then like it takes that assembly and says like, you know, what is some code that might have made it, right? You can imagine there are various different ways you can think about how it might do that. Maybe like with some things more recently, you would think a sequence to sequence transformer model might be very good for something like this. And you know, probably like the better ones like Ghidra do something like that. But Ghidra's a bit older, and you know, they probably just do some manual crazy mess. But anyway, yeah, so we got this, right? That's very cool. And what are we going to do with it? Right, so we like are initting a player, okay? We're initting a map, okay? We're printing a map. We're setting a signal handler, probably just so like you can't like play forever or something. And then what? We're like receiving stuff. We're moving the player, printing the map, and blah blah blah. Now usually for the smaller programs, I like to look at the code first. For the bigger ones, sometimes it's easier to just you know, run it and see what is happening. So here we see what is happening. Alright, just like by guessing, right? You can see that I'm just inputting the WASD controls to move it around, right? I'm like typing it and pressing enter to submit it. And then, you know, I can like move around. But it seems like most of the moves I do, every move I do deletes 2 lives. And what? And now you probably want to do something like get to the end. Sounds kind of reasonable. But what if we do the opposite, right? And try to like go over here. Oh man. So they're like obstacles, you can't hit an obstacle. It's like end, you can't hit the end. And you probably want to somehow like make it to the end, right? Since there's no libc, you're probably not like calling a function. Maybe you are. Well, anyway, we'll find out, right? So let's look at how the map is stored in memory. That would be like the first thing I think about. Init player. Program 1. Okay, sure. So what happens when you move the player, right? Player tile. Whoa, wait, there are like all these other things too? The WASD, and then there's what, P? What in the world? And then there's 1. What happens? Oh man, that's some crazy stuff. Right, so that's not really what I meant to happen. No, well, alright. Well, anyway, yeah. No, that's not a P. That's a L, right? L. Alright, I think that one, when you do it, you like it to change what character this guy is. Oops. Yeah, so I guess you gotta do like right after, right? So I'm gonna make it equal to, what, like a $sign. And boom, I just made equal to. What is P? Oh no. That was not good. P, what happens with P? P is what? You need to have parameter 2. Parameter has to equal to the end. Huh. Huh. What is this? D. What? So this like supposed to automatically solve it or something? What, like it died? Okay, sure, right. So this like an automatic solver where it just like tries to go right and then down basically, except for of course like it deletes too many lives. So that's what happened there. And what else we got happening with this boy? Let's bring this back to big. Hit an obstacle, right? Okay, cool. All right, so yeah, we see they're like these two things. Very interesting. Very interesting. Not very interesting. What? All right. But param 2. That, no. Param 1. Param 1 is the player position, it seems. But how is param 1 defined, right? It's local AB0. Local AB0. Oh, what do you look at that? It is, what? It is an int. AB0. Okay, it looks like that's an int both times, right? What else? What type of add is this? This looks, I think there's it. Okay, yeah, it treats it all as an integer. How do you win? Is there a win? That's what I want to know. I want to know, no. Local AB. What? Local AB? Where even is that? Alright, so like, you need to get to this position or something. Maybe 0. Okay. Yeah, all you have to do, it says, is ignore like the while loop. I think that's just like it like messing around. Or ignore like the thing down here. You can just like while true or something. Anyway, once it gets here and like a break in this if statement, all you gotta do is say what? All you gotta do is get to that last position, yeah? And what's AB4? Param4. Where is param4 ever used? You see? I'm not seeing where param4 is ever used. Oh, that's param3 here. It's param3. Is param3 ever used here? No. What even is that parameter? I don't think that's like ever used. Anyway, local AB4. Where does that come from? Where does it go? Where does it come from? Cotton Eye Joe. Wrong with you. Alright. I'm not sure what exactly this is, but we'll figure it out later. Anyway, alright, we can think. So this seems to be our map, right? We can just guess. This is our map. Like, you know, that big like block of things. It's probably like in memory. It's like that hashtag character, then that, right? That's like all like these. But then we can imagine, well, what happens if you go before that position, right? Well, you can think, well, if you go before that position, you can see that, like, probably these variables are right before that position. So you're probably just, like, supposed to move the little guy to go before that position, right? And do something like this, like 1, or, oops, wrong one. Right, like make it go off the grid, right? You saw there are no checks to go off the grid. Okay. Or apparently there's a check there. But there's no check over here, right? And then now, yeah, so you can see what I did is I went up here, and then I went to the right one. But then that led me here, right? Now we want to get more like move up here. I want to do something more like move up to the side. I think that's just going to make us go over here, which is not what we want. What we want is to go over here, go up 1. Imagine going up, wait, no, what? We do want to be over here, right? If we go up here, that'd be like the same as right before here. Right, yeah, so right now we're right before that position, because when I press D, we hit that. Okay, so you can see, right? We just want to go to the side over here, or like a quick way, right, is we just want to go, we want to go directly to the side until we get here, go directly over here, and then like now we're going to be able to change the integers and everything. And you know, just for fun, I guess we could like look at it, right? Game main var, this main, where's the loop? Loop. Let's just break here. Alright, so let's move one over here. Oops, I guess out of the wrong loop. Oh, that's not what I meant. Where's the loop then that we want? It's this one. Okay, so here, now we somehow got to that. Well, let's just do this, right? I'm going to move this a few to the left. What? Ugh, that didn't work either. Whatever. I don't care. One dish. Alright, this is main. Where is the loop that we want? I mean, let's just like find the move player, right? Before we move player, I'm gonna put there. Right, so like right before we go, when we call A, I'm gonna break. And yeah, so telescope, right? 50. Also notice that this is a 32-bit binary, I think. Is it? Yes. I think it's a 32-bit binary instead of 64. I'm not sure. What would all the addresses be below? I think it is. It doesn't really, it doesn't really matter. Anyway, yeah, so here's like our thing, right? What? No, this isn't. see. Oh yeah, right. So this is like a pointer to our grid. And this is the grid. This is where the grid starts, all the grid characters. And somewhere should be our block guy. Anyway, we're gonna move a few times over. What? Oh, it's gonna really. Alright, so I'm just like slowly moving up. I have to like press that twice for unknown reasons. And now here's where I move off the grid. Now, let's look again at our stack. Hopefully look right. Oh, right, I guess we gotta actually move. And now. Look at what, where is it? Where is it? Here, so 5F. I don't even know what's happening. Where'd our @ symbol go? Okay. 5F. Why'd it go here? Well, let's move one more to the left. And then Z. Sure. Let's do like, what? F, E, D. Okay. So now here we see, right? 2 characters before our this is this thing, right? How cool is that? But then that is like literally just where this AC is. Remember how we can like change the character or something? Well, I mean like, well we could just like, no. Now what? Now, well, now we can like change one of these characters to like suddenly be exactly what we want. So, let's say we like go over onto AB0. Right, we should see some like negative number. Okay. F. Okay, yeah. So we have like a little bit of buffer, I guess, before here. Well, I guess like the only thing we can go on is this, right? AAC 59, sure. What is this? I think we want to like go up to our auto solver. This is less than 59. Else, what does this do? What's param 2? Okay. somehow we want both our characters to be right. Yes. We want this to be... This one to be 5, 9. This to be 1D. And which one is coming first? Well, it looks like... that one is negative. Alright. I mean, let's like look at the grade. 29, 89. So right now, we are saying that we're at 1F. That's like 16 plus 15. I think that's right. Where's our position? Is this not our position? I think it is. And then this is our negative one, right? Because it's like when you went backwards from 0, it's like we went negative. Okay, but yeah, you can see where it happened in memory, right? Actually, I'm wondering if it's even simpler than this. What if I just go back like this? I go down. Nope, it's not that easy. Well, go back up where there's all our stuff. Alright, when we said I want to go back to the end of here. We were like lives left 31. That's 16. Oh, okay, right. So we want to go back over here and like make our lives infinite, basically. Right? Then we can just like move however much we want. I mean, sure, right? So, what in the world just happened? I accidentally closed it. / go to one. Make this bigger. This, okay. So watch this, right? I'm gonna do it by hand. What's gonna be, what you're gonna do is you're gonna go back over here. I'm gonna go up over here. Now, watch what happens when I keep going back. At some point, my lives are gonna become like infinite. There we go. Easy clap, right? What? Oh, you have to like do that 4 times, I guess. Oh, so you gotta be, oh yeah, you gotta be careful about that. Alright, but you get the idea, right? We're gonna go backwards. The thing is, right, you might ask, why did it become infinite? It's because when you go, every time you move, what's happening is it's turning whatever position you're at into a dot, and then making your new position, the new character. So when you go back, like over here, right, it's just setting your x to be like negative. So it's saying like -1, whatever. Yeah, so you're like going over here, and then right, you're just like going back until you overwrite that variable. and yeah, whatever. It's just like overriding it with dots, basically, like the bytes that correspond to the value. Anyway, yeah, so this is some easy stuff to do. So let's just, you know, get it over with, right? So let's just make a move. I mean, right. What is it? Like, just like that send line after X. C. Sure. Do we always start at the same position? It seems like we have to win 4 different games, which, you know, is a little bit annoying, but it doesn't matter. Oh, right. So this is saying restart, but this is saying what? Once you get past the 4th game, then, like, you know, you're done. What? Okay. Anyway. What was I doing? Right. Init player local AB0. Right, that's just the player thing. Init player. That's no different than before. You're not passing anything else. Should be at the exact same position, I think. Alright, I'm gonna assume it's at the exact same position every time. So wait, let's like look at the game. Alright, but I think it might initial. Oh yeah, it's like changing where this thing is, but that's really not gonna matter. Because what we're gonna do is we're gonna go back and then go forward. Oh yeah, so it's 1, 2. Oh, it even tells us our position. Bro, has it been telling that the whole time? Anyway, yeah, so you can see like over here. Huh? Okay. Somehow I made it not tell us that. It doesn't really matter, right? We're just gonna go 1, 2, 3, 4. Context binary E process path. Alright, and we're gonna move range 4, move E. A 4, you dumb. 1, 2, 3, 4, 5. My bad. Or I mean, let's just make it like 8, right? I think it's 8. And we're gonna range what? 5. I'm gonna move W. And let's just try that for now and see what happens. And it's not going to say flag yet. Let's make it interactive after. Oh no. Why? Oh no. Let's go to game. Yes. Yes. Alrighty. Okay, cool. Right, it does exactly what I want. So now we just gotta like move I back up, right? Or I in range. No. Move it say our position? No. W, oh, this should be S. That's not working. Range 4. Okay, that did what we want. Oh, I'm range 3. What's the lowest we can do? Alright. 7. We'll go 7. No. So we do need 8 here. Oh, cool. 0, 86. I think we're gonna need it to be 186. Well, let's just try it like this, right? Move down, overwrite lives. Oh yeah, actually this should just be like brown. Right. Down, overwrite lives. Now move up and auto finish S and then move P. Okay. Let's just try around, right? Cool, that worked. Now, let's just like 4 around. So 4 rounds. I don't know if it's 4 or 5. I'm just gonna like try both. It is level 4, right? What's happening here? What happened here? Local 14. What's local 14? Did we win? What just happened? I don't know what happened. I'll just try putting in like P. Oh wait, we can't even see the X. What? Where'd the X go? Actually, where did everything go? Okay. So the map does depend on the level. I don't know what happened there. Okay, what happens if I just do 3 rounds, right? Okay, now it says there's a 4th round. What is happening here? Well, it's putting this thing in like a random spot, it seems like. Except for it appears to be nowhere, which is kind of dumb. Okay, whatever. Local AB4. Well, this is not equal to that, that's not equal to that, that's not equal to that. Okay. So it seems like we also need to set local 1.4 or local AB4. Oh, I'm so confused, sorry. Alright, first off, I'm just gonna make this a function. What is that? Is that the best name? Probably not. Anyway. Use lack of down check overwrite files on stack. Okay, so what we're gonna do is this and then gdb.attach. Oh, we need attach B. Right. So then that will allow us to open up GDB at the state that it ends at. Yeah. Telescope SP5 10. Alright, so what's happening here, right? SV 20. C4. I guess we want like one of these to be 5, AB4. AB4 is gonna go up 4 times. AB5 is gonna go up to 5. Means 1 more is gonna be 4. Stack. How do you do a stack trace? I already forgot a stack. Right, it's a stack trace. So what? I'm at main. Move player. Solve round. So it's at the solving. It's in the middle of what? Solving the round? Sure. Anyway, yeah, I'm at the move player, right? That's good. Where's the move player? I want to break right after this. Alright, now let's see what happens, right? I should be. I would think I'm in the right spot. What just happened? Why am I at level 1? Hold up. Where'd it go? Okay. I see. It didn't start when I thought it would, I guess. I see. Alright, what I'm gonna do is be in it. 2 and 3. And now I'm gonna break at what? Solve round. Trace. Now I'm gonna break at the one after. Leave the player. Alright, now let's see what's happening. Okay? So I'm going down here, going around, I'm calling the print map. Now compare EAX, it's good. Compare this, it's good. Compare this. It's equal. yay x was equal to 0x4. So we jump to main plus 342. Now, compare what? What are we looking at? We're looking at EBP minus that. Okay, we're basically doing the same checks. Right? I guess, I don't know, some double check to try to see you're not tricking it. Now, wait, whoa. AAC, where's AAC? Before, what was it before? 8. Right. We checked before. That AA8 was 4. Now we want AAC to be equal to 5. Okay. Sure. Oh, that's so annoying. Alright, I'm gonna do it a different way. Move. Alright, so we're gonna do this 3 rounds. Rounds. Now what we're gonna do is for I in array overwrite some variable 8, not 8. Alright, let's look right. What do we overwrite? We just overwrote something. We overwrote something. Kept overwriting the lives. Where does it say the lives? I'm not sure. AAC is the lives. Oh wait, what? AAC is not the life. Maybe 0. AC. Maybe 4. This is calling this AA1. wait, this is like going backwards. A1. EV4. Okay. What's the one that we're changing then? What is, I mean, we could have just looked at it. Where'd it go? Oh man. I don't have the GDB open. Okay. That sucks. I'm gonna have to go through it again. I don't want to go through it again. Where was this thing? I know we moved up. AB4. Okay, what it's saying now is on the 4th level, we actually need to change the level number. Okay, I see. On the 4th level, we need to change the level number. We were changing AAC range 12. Oh yeah, actually let's just do over life. Fourth round also need to change round number 5. Over life range 8. Alright, let's make sure we know what we're doing. AA1. AA1 is here. AAC is here. Yes, so we went 8. Why do we have to go 8? Seems too far. Yeah, it should be too far. Anyway, let's try 7. Move A. And then move E, what is it, L. L plus P8. What is this? 4. Let's see what happens if we do this. Okay, so we need to move S, A, move W. What is happening? Okay, it seems like we did not move the right position. And let's just try this instead. Nope. 4, 8, 12. Where is it? Okay, that got us close. I think it's like plus a few more. That seems to get us the largest byte, actually. I think it's 15. Yes. No. Level 46? What are you talking about? What is that? What is that? I don't know. Oh, okay, first off, how are we supposed to make it equal to 5 and stay 5? Okay. Well, we try to make it equal to 5, obviously. I made it equal to not 5. Alright. That's taking a lot longer than I wanted. Where is the one that I missed? What did I miss? What is the dot first off? It is one of these. Yeah, there's the 46, huh? Are we sure it's... And this is not equal to 4. Wow, this is not equal to that. We need AB to be equal to 5? How? Alright, first off, we can see if we do this. Oh, no. What? Impossible. Impossible. E4 is an int. Let's check. It looks like you'd want this to somehow call when it's 5, when it's 4. But how do you do that? What does when do? Okay. I mean, instead of dealing with the game at all, which seems impossible, we could instead try to just like overwrite the return address. Is that what it wants? Well, that doesn't seem right either. Print on player position. If this char I see. Okay, so that's why. It really like looks through the grid to try to find where you are. And that's why it doesn't print when you go out of bounds. What am I missing? AB4 is not equal to 5. How do you get to the 5th level? Okay, I am not sure what is happening right now. Somehow, we need to get this variable to be 5. I'm wondering if I should just try to overflow the stack. Why am I being so bad? Should not be hard. Int. Local 15. Local 15 says it's a char. Where's local 15 used? Oh, okay. Get char. Well, local AB4, the level. It's also passed to move player. Yes. What's param for? He said. var 1. Equal to this. Okay, and it just needs it to pass in here. What? What am I missing? Come on. Alright, I guess we need to like analyze Mr. Stack. and see what else he's giving us, right? What is Mr. Stack giving us? I'm not taking it. So a pointer to this. No, it doesn't matter. AB4. I'll go to AB4. 5. Why would I have this set up if it was not supposed to be like that? Bro, what are you doing? It has to be like this. AB4, AB4. I'll go AB4. It has to be 5. And it's not equal to 4. Wait, and this is not equal to 4, right? Wait, so somehow, so this should only be 3, and this should be 4, when you like can't even use this, right? Okay, it has to be just trolling then. I think it's just trolling. That is so mean. Why would they troll me like that? Alright, what we need then is what? Okay, what I want to do this right. Telescope SP 100. It's 2000. What's 2000 over 4? That's still quite big. It's gonna be like 500. Telescope SP 600. How big is it? Oh, 2700. So we need what? That's the extra. Just 700. Okay, we get something. Alright, what do we have access to here? So what happens if memory after this? What is this? Can't even know. Where is win at? Right, win is here. Where are we returning? I don't think we can jump there. Well, let's look closer at our code. Does that right have something better than I'm realizing? L. Get char player tile equals this. Wait, hold on. What? Ram. Wait. Oh my. Okay, this has got to be the dumbest, stupidest thing. Oh my god. That is so freaking dumb. It's literally just like safe if not safe. Okay. Was that what I want to do? Oh, never mind. That's not what I wanted. Okay, sorry. That is not what I wanted. Okay, the key thing is that when you get here, you don't make this move. Don't move up before, or else overwrite with. Okay, this is gonna work. I was so dumb. And that's what I got. Oops. Wasn't so dumb. Now it's not too clear, actually. Alright, wait, if we PG... Never mind. I don't think that was the right idea. Okay, but we see here, right? This is where it sets it equal to a dot. Wherever we're at is set equal to a dot. It's the same formula. What's param 3? Do we know param 3? Let's find out. Param 3. Local AA1. Oh, that's just like offset from this, sure. So wherever we're at is equal to a dot. And then it moves. And then it sets our new thing. Okay. I still don't get how that gets us around that. Dot. No. Oh, what? I'm trolling here. Alright, I was hoping the auto-solve, or for a second I thought since the auto-solve comes before the dot, right? Just set the player tile and somehow it like works. But no, it's using the move player, so of course that doesn't work. Param 2. Okay, well we do know, right? Anytime it's not equal to 4, it's gonna keep going up. Sure. Doesn't help us that much. 4, 32. Is there another way to move? That's what I want to know. else can I get to win? Where's the winner? Same thing. I mean, it's like, apparently we forgot to add it. Well, now you get to see what it looks like when I am extremely stuck. Well, this is like supposed to be an easy challenge, so I don't know what I'm doing. And be in layer 3, 2. So it does say compare this with 5 AAC. Or it does say before, compare it with 4. Wait, no, where is it? I need to make sure I'm looking at the right things. If this is equal to 4, only an EAX, AAC equal to 4, we jump here, 342. Now, what? Wait, bro, that's so dumb. Okay, so easy. The only way to jump there this level 4, we jump to it. Okay, never mind. Right, just like, as long as it's not equal to these. As long as either of these are not equal, we jump to here. Sure, right? But now, down here, jump. We need this equal to 5 to get out. Telescope 100. What are these, right? Should I look at the hint? Oh, that would be so sad. I have to look at the hint for this. That would be extremely sad. Where? Oh my God. 5, not 4. is equal to 4. It's not needed. Equal to 5. Okay. Why would they have the right character if you cannot write, right? There has to be a way to write a character. I believe that is probably true. There has to be a way to write a character. I mean, oh, wait. Well, I can go and like try to write on my position and then try to write there. I mean, let's say I go and write on my position. Where would I write to? Right, so what I'm imagining is what if I go right on the variable that holds my position, which I guess is maybe this. What if I write on this variable to make it point somewhere? Where would I point? Where am I at? 804. Where is the return pointer? 804. I don't even see where the return pointer is. What? Yeah, maybe I did not go far enough. I wonder that now. Oh, yeah, that is what happened. I don't know what I was doing there. I mean, I could go. I mean, I could just go walk up here, right? Just like wreak havoc until I make it to here. And set this equal to win. Where's win? I'm gonna be such a troll if that's what they want you to do. 800497 BC. BC. What do we got? BC. Nine, 7. Where is right here? Yeah, but it's still asking you if param1 is equal to that. There's some format. Where's that? Where are the other format strings? Okay. I'm thinking crazy thoughts now. Alright, I'm thinking crazy thoughts now. But what if we went, overwrote our return pointer to jump right there? I actually think that might be it. Right. Let's see, where do we add that thing? Should be ink or add. Add. Right here. 9986. What is it at? It's at what? 9871? Oh, that won't work. Is there another area? Oh wait, but we're at init player. Wait. 992C. Okay, yeah, see? Look at right there. Where is this compared to what we're overwriting? It actually should only be a few more forward. Yes, what if I go right there? Bro, that's crazy. Okay, we're trying some crazy stuff now. But what I think, fourth round, overwrite, return on stack in move player to jump inside main to and +1 on level. Over life. I mean, over life. Now we're gonna move. Now have to go more than 4, right? A few more. I mean, we're already here. It's like, what? Let's just try some intervals of 4. Okay. I think it's 15, 19. I think it's plus 4 more. 23. And then I think we want to go right here. Just 8C. Actually, we should do this first. And then let's not do this, but I'm very curious what happens here. No, 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 no. Wait, wait. Oh, well, for one, we didn't even do it right. 8C. Try again. I mean, let's see what's happening at least. $28. 3. Five, 6, 7, 8, 9. What am I setting it to? Setting it to something. Whatever win was. Where does it go? I'm gonna see where it's actually being set. Why are there two terminals? I mean, look, right? We were like overwriting the low, right? It should be. And that was, what, 23? It should be this. It's just 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's just try that. Now that is interesting. What happened there? Huh. Well, that did something. Actually, what did that even do? What? What even happened there? Hey. What? I gotta have it. What happened here? Oh, wait. What? Oh, never mind. Okay, unless I'm here like the wrong way. Wait, where was the one I was at? Also, doesn't move around. Where's the one that changed the level? That I was like at for a while. I mean, I thought it was the 5, but apparently not. At 19. No. What? I thought it was 5. No, I guess that is not wasn't quite enough. 6, 7, 8, 5, 8, 10. Let's try a few different ones, right? 8. One of them is gonna work. Seriously. What? Okay, I don't know where this went. One of them is supposed to change the level. Okay, there's that one. Please. Alright, so 3. I thought it was 5 before. Maybe 10. Oh yeah, I thought you could just see that. Oh. It seems like that one was hit. What I want to do then is hit one more, 11. did something. Does seem like 11 is doing a lot of something. Well, not really what I want, actually. Why is it doing that? Well, what if I change this to 8? B? Or what's the instruction for it? Oh, it should be 8-6. My bad. My bad. Yes! Let's go! Yes, 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 yes. And now. Yes, sir. Oh, we have to do now. Also, I realized that it's blue because it's a function, so let's not do that. Yes, it should work. Actually, I might have not put a flag file. Oops, echo. Actually, what happened? Why did I do that? Yeah, let's go back. Oh wait, it's because we shouldn't have this. What? What? Oh. Bro, what just happened there? Alright, I must just like have the wrong here. Oh, actually, anyway, let's just like go over one more, right? 9. No, I'm gonna do 8. And just like what? Move L. Was it initially? What just happened? What did I just do? Did I change that? No, I did not. Oh, that should be L at. My bad. That's annoying. Oh my lord. What is happened there? Hold up. Why did it restart? Oh my. Oh, gee. What the? Hold up. Oh, I did get the level to be 5, so that's kind of nice. But, oh my god. It's supposed to not be 4 here. Well, then be 5 here. What? That's impossible. Oh. What? That is not okay. I mean, well, nine, 7, 9, 8. Can I get to 9, 9? Alright, we did 9, 7, 8, 9. So when we're at move player, where are we at? No, it's not doing it from there. It's doing it. 9927. Where's the next 2? 7. Well, what if we come from another spot? A, D. Alright. Somehow made it from here. Greater than 1D. Yeah, that's not gonna happen. Shoot. Man. Alright. That is evil. This is evil. Evil, evil, evil. What am I doing? We need this to be 5. Actually, I'm not too sure. Oh, that's why. Alright, I mean, look, we jumped to here. This is just something on the stack, right? So instead of jumping to here, oh, what if we jump to FE? What if we jump to FF? I mean, let's try it, right? Because, like, why not? FF. Let's see what happens. Well, FE. Did I look at this right? 99 FE was right here. Look, move player would have gone 9927. I was making it go to 998C. I want to say instead go to 99FE. Let's just like see what happens. Huh. This says it exited normally. Okay. Let's do something different. We are making it to win. And then what? Well, let's think about some other things. Why would it be 32-bit? Why? What if I do this? Okay, so let's like take all of this stuff. Right. Right. I think. Oh yes, this is gonna work. Alright. Slide main. Jump around. C8 6. Now overwrite. Jump straight to win. Oh, I think it's gonna work. It better work. I'm gonna be. What? Oh. I mean, why would we not just like do this? L that. I mean, we know it works, so whatever. Sure. Oh man, what? How could you do this to me? So what happened? I was going over here. Yes. Should over life either time. L at. Yes. Wait, why did not work? For some reason, it's not working here. Okay. Problem is that the stack is not aligned the same. Of course. I mean, why would it be, right? Shoot. I mean, not this. I think this idea is gonna work. I just gotta figure out where that return address went to. B. One, 2, 3, and 4. Now the level should be. Oh, what happened here? Oh, it's like, sure. Sure. Wait, why do we continue? Alright. Let's do this and that, sure, whatever. Alright, stack like 20. Alright, now it's here. Now it's like 5. 1, 2, 3, 4, 5, 6, 7, 11, 12. Okay, that seems like it's 12. That isn't really what I expected. Alright, I'm gonna make this Y and this X. 11. And try this and hope it works. Hope and then hope harder. Where'd it go? Let's just try 13. We're just gonna try a bunch of them. It's 15, and then what? I wanted to break in when it did make it. Yes, hopefully we made it. Now what happened that went wrong? What happened there? What? Okay. What is that? EX is 0x5? Yes. 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 Oh, yes. Yes. Wait, so it works? Gosh. Oh, that's amazing. Alright, that was quite the challenge, I'm not gonna lie. Right. It's like simple, right? Like it's not like using any advanced knowledge. It's quite the little puzzle to get that. That's such an evil idea. Alright, I like this challenge. It was a good one. It was quite a bit harder than the previous ones. So like jumping inside of functions and craziness. There you go. Whew. All right. One more. I cannot believe that one took that long. Right, like format string 3 took me like 5 minutes. I think that took me like 5 minutes. And why did that one take me so long? I wonder if I overcomplicated it. Right. Did I overcomplicate it? Who knows? Right, that seems way more complicated than it should be. But somehow that worked. That was crazy. That was crazy and luck. I think some people might not like that type of challenge because you had to do, like, you know, it's just like luck that the addresses work out. Well, I don't know, I kind of like a puzzle like that. I don't know this author. I know this author. Pepsi. But anyway, alright. Now, time for the final one, the supposedly real challenge. We'll see if that is the case. Man, I was spent so much longer than I wanted on this. Alright, so we're dealing with libc 2.35. Alright. That's nice. And alright, it's already like linked to that. Alright. Cool. And it actually gives us the source. That's it. Wow, that is short. This is the final one, and it's like that short. That's pretty crazy. Alright, is it using some like crazy stuff from somewhere? What is... Oh wait, additional stuffs. Additional stuffs. What is gonna be the additional? Alright, just that, really? Alright. I mean, what can you do, right? Alright, so we have main. We basically have this forever loop until that. And alright, let's see what kind of stuff we got here. Packet. Put L. Well, everything's using put L, it seems big, more or less. So I wanted to look at that first. That's just a printf. What's that fancy stuff? Wow. Okay. So we read in some stuff. What do we read in? Read in some stuff into the size variable. And then we malloc that. And then we make the size. is this? Oh man, my eyes are starting to hurt from looking at this stupid screen. Oh man. Alright, packet size. Equal size. Where's the packet? What is it? It's a packet T. Struct packet T. Alright, so size and data. Sure. Here. Alright, so this is just like some sort of heap creator. Seems like any size is okay. Now where is the problemo? Switch. Data 0. Okay. Alright, the first one says, like, what, the packet, something. I don't even know. Packet opt ping. Ping. Packet message data. Ping or echo. Ping. Echo. Or trade. What is it? Trade? I don't see that. Alright. Yeah, so here you get to allocate some memory. That's nice. You get to read in, and the first byte of that seems to be going to this enum. It tells you what you get to do, and then it will tell you what. And does this one just give you the address of this? The address. Yes, that's really all it gives you. What it gives you? Alright. Are you sure? It gives you one character of the address? Question mark, question mark, question mark. That's a weird one. I guess all my views died with my bad performance. Fair enough. Then you don't get to see the awesome. My very awesome thing, whatever. What are we doing? This. Alright, let's do this now. My name is right. Yes. Okay, should be fine. Pepsi pool. Where are you? Switch data 0. Well, alright, I guess like the first things first, you know. You gotta say check stick empty. Alright, yeah. So pi, whatever, no surprise. Alright, I just realized. Oh, what is this? What? Alright, and also, this seems like it's yeah, this is a pointer, right? It's giving you the location of this character. Why? That seems so dumb, but whatever. Alright, you get to allocate any size. You get a heap overflow. Wait, let's check libc also. Partial. Okay. All right. Let's do the heap trivia, I guess then, right? I do love some heap trivia. Heap overflow. What can we do with that? It is quite weird. I'm tired. Right. What do we even know that has a heap overflow? Alright. First off, like the things we know, right? We malloc a big fat size. It's gonna end up near the libc. Like a big mmap chunk. And you know, everyone likes a big mmap chunk. I don't know what -g is. GCC -g. What is that? Source. Okay. Sure, it's some debugging stuff, which is nice. But whatever. What else we got? What else we got? What else? What else we got? Now, you try to overflow onto libc. That should not work. Right? Is this data ever freed? I want to read it like this. Whatever. I might be too tired to do this. But I should probably just finish it today. What is the last step? else we got here? I mean, I should just like start actually doing stuff. Okay. I guess like I see 3 possibilities. 1. Somehow House of Force was brought back to libc 3.5. I find that extremely unlikely. Number 2. You somehow well, I mean, somehow you get... Oh, okay. I mean, somehow you interact with things on the heap. But each thing will probably be going after the other. There's no freeing. And... I don't know, it just seems weird. I guess the only thing is, like... What? I don't know. I don't even know what you go for. Character. Yeah. Oh wait, no. This is printing the data. This isn't giving you the address. Yes. Passing the pointer so it can be a message. This is 8-byte aligned. So just to ensure it's 8-byte aligned, I guess. Oh, to do, but can you use that? I don't think so. So this is also going to be 8-byte aligned. Alright, let's just, real quick, let's pull up good little heap exploit list. Yes, my favorite website. You know, just like. I mean, let's just look through the unpatched techniques, right? Link a fake chunk into the unsorted bin. Okay. See, the thing is, it seems like we need something without a free. The only possible exception is perhaps we're putting stuff on the stack with the printf. No, we're setting the buffer. And that printf still allocate on the stack. Does gets allocate on the stack? I don't think so. Those are kind of our possibilities. Generally, has been doop. House of Spirit. Yeah, see, relies on free. Clear, approve, and use bit. Force backwards consolidation. free it anyway, right? There is no freeing. There's probably... Now why... Any reason for this setup? Why the colored text? Right. I feel like... I mean, like... It could just be like a little theme. I feel like things like that don't happen for no reason. We use a fake, non-main arena to write to a new location. Alright. Due to glibc, blah blah blah, blee blah blee. Uni Lakeless prev size of mmap chunk when it's freed, allocated again. Its overlapping part, memory. I set a challenge with this before. Overflow free export. No free export. Wait, where? Table. Where is this? This is just a global. Okay. Wait, where is this initialized? Oh, yeah, alright. House of Orange exists. Though, like, it's hard to make it work on the new ones, I thought, but let's go ahead and look. Wait, well, this part's supposed to still work, right? I mean, so then, like, House of Orange. I already said the version was new, right? And I guess, like, we want it to be recent. Okay, well, you know. You know if it's a Chinese page, right? It's bound to be some good stuff. Hopefully there's someone that lets me translate. No! Oh, why would you write that? What are they doing? No. Alright. Oh, is this something? Okay, one of these. Alright, well, It is looking... Alright, I really only see 2 cases. You see, without a free function, we are quite limited. However, I'm sure Mr. Printf is doing something, right? Free with printf. CTF. Right, wasn't there what's it called? CTF heap allocate with printf. Let's see, let's look at BizBuzz CTF printf. BizBuzz. Alright, let's look through these for some inspiration, because I'm pretty sure he wrote about one of these. This one, maybe. Is this the printf one? No. What is this one about? This is not that, maybe. No. Where is the one I desire? Really? Oh, where are other here? Oh, look at this. Are you sure it's not this? Not that. Then what? Then what? No. Alright, whatever. I don't think this has what I want. Alright, what? I know House of Orange can be extended a little bit. As Eclipse 2.3. Da. House of Orange. Eclipse 25. And let's make it only be in the past year. And oh, you look at that. Whoops. Where should we? Alright, I need to like make it not be. When was the CTF? I need to make sure I'm not doing that. From. Look, I want to say from here. Let's do like here. To when was PicoCTF? It wasn't before March, was it? Apparently it was. 10. Alright, what do we got here, right? We don't got much, but we got something. See. No, stop showing me the old ones. I'll go back to like here, okay? Zero solution for that. What the? Oh. Okay, now this one has free. It doesn't seem like it wants. Well, this is the only one that maybe has a chance, I guess. And it's why didn't I ask to translate? Okay, I don't care. Well, I think House of Orange does the freeing part still work? What about this? Well, these are like the new kids on the block. Why is it not translating? Where's the translation? Yes, there's lots of new IO things. That's not the part I care about, right? Let me just look at like CTF key. Like it's been too long since I did this. I don't remember how these things work anymore. Right, we have House of Orange, and it does some magic to make a I guess we should like actually doing some experiments. Yes. Alright, let's make the size big. Oh, bro, it makes it so hard to read. Okay. Oh, I'm too tired to do this. Okay, so first we want to make some sort of some sort of mallet chop like this, right? Or we want to say we want to do size, what do they call it? It's opt down. So I'm gonna say PS after what? It's like what? P64 of size. Basically, sure. That's not enough. What is size T? I don't know. I just don't care. Then does it ask anything? Skits. Line. Well, let's just make sure. A, it's like what, P? Send line after P4 alt plus 1. Okay, I mean, this is mal chunk. Let's just say like what? 6, 8. One, comma. No. Alright, yeah, I'm just trying to create a little mallocating helper function. And then, no. Drop those. And, right, so, because the annoying part is how you have to send like things in bytes. I need to print this to make sure. Okay, cool. Did what I expected. But what if I 0? It should be none. And if it's 2, it should be some error. Cool. Okay, so now, right, let's just like malloc some chunks. This 1, 8. Right. You know, let's just like some chunks, right? X. Chunk. Alright, let's just see what happens, I guess. Right. And let's break here. Alright. What is the info? Info maps. What? Oh, I don't even know this. DB. Yeah, here's this. What is happening? Oh, why is it looking like this? How am I supposed to read this? Where's just the what's that? Like the most important thing. Okay, so let's take a glance at the heat. And yeah, so here I just like, these are the different address ranges, right? You know, here's like the actual program, here's the heap, and then here's what, like the group C and all the other stuff. I want to do set heap equals how do you var gd set I forgot. PDP, where's my good friend here? Why is it? Room. What is that set? This, and I'll do that. Okay. Yeah, I prefer it like this because I don't even know why. Yeah. I like it more like this. Okay, but yeah, here's our heap, right? Heap always has like the size and then the content. This is the top of the heap, so this is like the tcache per struct thread. It just like has information about tcache, but you know, obviously we don't have any of that. Where is our first boy, right? Here. Here is something. I don't even know what that is. Why is there 18 there? Actually, yeah, what is that? I really don't know. Maybe 115. Here's this, right? Let's move the next one. What are these? I actually don't know what that is. 1948. 258. Where are we reading this into? Size. Sure. I mean, what is it then? Where is this coming from? Right now we should be getting what? Some sort of new boy. 20. What is this? I don't get why it's being put there. You know? Alright. I want to also right here. Why? Alright, whatever those last instructions were, put that on the heap for unknown reasons. What? That does not make sense. What is happening here? Oh, you're so dumb. Oh. Sometimes I forget you're so dumb. Okay, sure. Yes, I forgot about that, but the size is going onto the heap. Sure. Why? I'm not entirely sure. But that's the way it is. It's just the way I like to live my life. Where's the new boy? What is the threshold? There we go. Now we got this right. Oh, okay. Oh yeah. Actually, what I'm trying is I want to try to make the printf allocate some memory and see what happens with that. So let's just like go right before it calls one of these. Is the whole thing inlined or what is happening? No. Where's the calls? Oh, there's the call. I mean, let's just do it like this, right? Here and here. Let's just like look at this first. And we see we got this, right? We got this chunk. This, and it's gigantic. Where's the end? Come on. I mean, like, there's like, Yeah, I did do the right one. Okay. Does printf allocate? Well, okay, whatever. Let's make it this, right? No malloc free. I just want to make something malloc free. Oops. Oh, wait. Alright, let's see. Oh. What happened here? Oh. Is it just too big? Oh, wait, actually what happened? Alright, let's see. Oops. Alright, yeah, so I'm just trying, like, can I get any Malachor free anywhere else? And the answer seems to be a big fat no. Okay, so I'm just gonna assume then that means no. Right? Actually, I mean, it must be because of the set buff or something. But I did really think that the printf would do something. But it does not seem like that's the case. Right, I thought, like, why would you add that? But I guess it's just for fun. I don't know. For now, we're gonna assume it's just for fun. Because otherwise I don't know what to do. So, with that out of the way, it seems the only reasonable possibility is that, what? It's that it's House of Orange, right? Oh man, I'm so tired of this. I'm not even that tired, but I am tired of this. No, should I keep going? How long have I been going? Oh, way too long is the answer. How long? Oh, like 5 hours, of course. Alright, it has to be some sort of House of Orange. The question is, of course, what? So looking at Mr. House, Mr. Mouse, Mr. Baga, Okay. I mean, let's just try this and see what happens. Right? I mean, why not? So, okay. We got a Malik or boy. Here it says return 0. And we're gonna move that forward 24. But this is plus 24, right? That's 20. We're taking out 8. We're taking out 1. Alright, I think it should be this. P64 is 1. Something like this, right? Now chunk 8, and then now chunk 6. Why do I always end at 8? Because that's like how the actual size boundaries. Anyway, let us see if this does what we would hope it to do. Alright. Alright, so that one is just the kind of Malik we would expect. Very cool. Here, we then Malik this thing. And will it cause a free? No, it causes an undead. Why? Let's see what happened here. 291. 1. Alright, we made this 21. And yes, this overflowed over to here. And we made this that. I mean, alright, let's try it, right? Except, well, this time we're just like, this time, what are we doing? We're just seeing what was that trick initially, right? Before it was 2. Alright, let's see what we got. 20D51. So we want to make it 1D51. Okay, sure. 1 D. Wait, what? What did we say it was? Oh no, let's just try this. Right? Just for fun. For funs. so first we have... Alright, where's our Malik boy? Malik, Mr. Malik, where you go? Alright, what? How do you get killed already? Oh, wait, what? I don't even know what. Alright, I think I put the wrong size there, but I'm not sure. Doesn't really matter though. Anyway, what is it? 1. Oh, I can't even see the original. My bad. That was my bad. Let's do it right after the Malik. And just in case. I think we need to keep doing that. D51. That's so weird. I mean, let's just see what happens, right? There's one Malik. There's 2 Maliks. That one worked. And there's another Malik. I didn't see any free. Okay. Okay. Did I like not follow the right thing? I wanted to see. Alright, that's 1. It's 2. It's 3. Okay. We do have some weird stuff here. Yes. That's definitely some weird stuff. After that, the original top chunk will execute in free and enter the unsorted bin. Okay. What? What even happened? It's 18, 2008, 68, right? Is those three. And yet we have 18, the 68, and then the 2008. Alright, that's weird. Weird. It's weird. It is called int free, right? Wait, I wanna see what actually happened. One, two, three. Alright, I wanna go through and see what happens. Okay, so we like jumping through. Let's make this a bit bigger. Alright, we're just jumping through. And we're going over somewhere. Unknown reasons. All this. What is this? I have no clue what we're going into. Oh man. Yeah, now I just... What in the world? Okay, this is very insightful. Well, it does look like something happened, right? That's not the main thing I care about. And you know, let's just like print it, right? don't even get what happened. Alright, let's just go here, right? 1, 2, 3. Soka. I see. I get it. Sorry, we're getting 0 because we're printing from right here. Yes. Instead of here. Okay. Well, that makes sense. Unfortunate though. Hey. I want to malloc one more. Is it gonna go there then? Or where's it? No. I mean, this should be... Hold up. Alright. One. Ugh. Oops. My bad. Alright, let's see, where did that second chunk allocate to? First one is obvious. The second one, oh no. I should be able to just do this, right? The same effect. I think this should work. I don't know why you did that. Anyway, look right. Let's see what happens again. What just happened? This, right? 1, 2, 3. Right, look. I'm not doing 3. Oh. What happened? Here we got our 1008. Yes. Here. 2008. So where'd my other one go? Another one before you. Okay, so this one supposedly is right here. 220010. Well, this one is actually. Wait, what? Oh man, what? Well, this one is a lot after that one. Like quite a bit. Very interesting. Yes, it does seem something is happening. Actually, what? No, why are we not? Oh, it's just that. Oh. Gets put some null byte, doesn't it? I mean, what if I put like that? If I do this. If I do the big one. Small one. Oh yes, you can see our new one goes right here. And this one is moved up and keeps that. Well, there's no reason. have this chunk is what? What is this chunk is just what? What is that chunk? Let's go to this guy. Where's his blog that has the House of Orange? This one? Orange. I thought he has a one that actually used it. Okay, I don't care. I like this guy's blogs a lot, they're very good. But anyway, what are we gonna do about this? I'm tired and want to sleep. I haven't solved this yet. Oh man, 4. What? Oh man, my eyes hurt too. Why wasn't this translated? I thought I... One. Why are these translating? I know First of M is one of the big ones in the new. Alright. What do I have, right? I have something in the unsorted bin. A freed thing in the unsorted bin. And I can completely overwrite whatever I want. Link a fake chunk to unsorted. Tampering inline. force macro process. What happens? Okay. I mean, look, right. We have some boy from the unsorted bin there. I mean, yeah, we should be able to do something. Come on. Here's... Oh, we're not gonna translate again. Why is it not translate? I think I've read this page. Where's like the table of contents? Large bin attack, right? Free chunk, leverage that, buddy. CSDN never translate for me. I don't know why. Let's try this one, you know. No, why not? I don't even know what house corrosion is. Yeah, max fast. It's the dumb thing that shouldn't exist. Does global max fast still work? I thought it was yeeted. Sorted and overflow. Let's see. 2.35. Yes, I vaguely remember. And I remember that's like kinda dead. I'm not sure. I am too tired for this. Eyes hurt quite a bit. Okay. it's just unsorted values. Attack. Let's see, 2.5. Something like that. Lore. See, well, I did solve this one. Maybe it's something useful. No, it's not. Okay. Okay. Well, I think I'm too tired to keep going. I'll finish this tomorrow night. And yeah, I probably need to actually be looking at the glibc source code and figuring out myself instead of trying to read some other stuff and seeing how that goes. But you know, yeah, I feel pretty confident we're using this idea, the House of Mr. Orange thing for the free. I just don't know what for sure after. Let's look at these. Yeah, I think it's just gonna be something fairly dumb, like a sorted bin type attack. But you know, I'll figure it out tomorrow. Because I cannot think. I mean, like, I could barely think at the start. But maybe you learned something. Probably not. No, it's probably just a big waste of time for me. But whatever.